forever, so I just started pouring it in from a vial. It was a lot faster to do it like this, but it wasn't nearly as accurate, so I ended up missing with a bunch of the copper. However, this really wasn't much of an issue because not including just a small amount of copper wasn't going to make much of a difference. When it all eventually melted, I mixed it around like before, and I let it sit for a few more minutes. I then went to pour it all into the same can, but I was a bit surprised because liquid metal started coming out from the side of it before the front. This definitely wasn't a good thing, but for the time being, it was still a bit too hot for me to investigate. So for the time being, I put the crucible back in the can, and I turned off the torches, and I let it cool. When I took a look at it a few hours later, I noticed that there were some huge holes in the side of it, which were made by the torch flame. This is why you aren't supposed to use oxidizing torch flames on graphite for long periods of time. I was lucky it didn't end up being a problem, but it could have caused the crucible to break when I tried picking it up. This could have not only caused all the gold to spill everywhere, it also would have been a huge safety hazard. But anyway, getting back now to what was thankfully not a catastrophic failure, all my gold alloy was now in this can. So I just quickly got rid of all the water, and this was what it was like. By dumping all the liquid metal directly into water, it created these pieces that have relatively high surface area. Ideally though, they would have been a bit flatter and looked more like cornflakes, but I think I just didn't pour it from high enough. In the can, just sitting on the fiberglass, I also found this chunk of alloy which had leaked out the side of the crucible. So I took this, along with all the flakes, and I put them in a beaker. Then, on top of all of this, I poured in some dilute nitric acid. A reaction immediately started, and some nasty nitrogen dioxide vapors started coming off. The nitric acid was attacking all the copper that I just inquarted it with, as well as any other metals that might have been mixed in with the gold. In this case, the other major metal that was used was probably just silver. There might have been small amounts of other metals though, like nickel, zinc, or iron. The nitric acid converted the copper metal to copper nitrate, which like I mentioned before, has this really nice blue color. As the concentration of the copper nitrate increased though, it slowly shifted to being a dark green. The silver and other trace metals are also being converted to nitrate salts and getting dissolved into solution. The silver nitrate is colorless though, and there isn't enough of the other metals to really affect the color. When the reaction died down, I added another load of dilute nitric acid, and it started bubbling like crazy again. I waited for this to also settle down, and when it was done, I dumped everything into a larger beaker. I then kept adding more of the dilute acid, and I continued the same cycle. As I mentioned before, I'm using dilute acid here instead of the concentrated stuff, and there were two major reasons for this. The first one is that it stops the reaction from getting out of control, and the second one is that I needed the extra water to dissolve all of the metal salts that I was making here. A major effect of this though is that compared to the concentrated stuff, the reaction is slowed down quite a bit, which makes it take a lot longer. So to speed things up, this reaction needs to be heated, usually close to the boiling point. I didn't use a thermometer though, and I thought I was close enough, but I don't think I was. And because of this, it would initially react quite a bit when I added more acid, but then it would kind of just stop. However, just by looking at the stuff at the bottom, I could tell there was still a lot of copper left. At the time, I thought that maybe the acid was just depleted, so I dumped off the liquid and I added new fresh stuff. The same thing happened again though, so I started getting suspicious. But still, I decided to dump everything off and to add more fresh acid again. This also eventually stagnated, so I dumped in even more, but it didn't seem to do too much. It was only at this moment that I realized I probably wasn't heating it enough, so I cranked my hot plate to maximum, and the difference was pretty obvious. I let this react for another hour, and it got rid of pretty much all of the copper. Just to really make sure that it was all gone though, I boiled it one last time with more nitric acid, except this time it was a bit more concentrated. When it was done, about 40 minutes later, I dumped it all off. What I had now was this really soft gold sponge, but it was still contaminated with a lot of the dissolved metals. To get rid of them though, it was quite easy, and I just had to wash it with boiling distilled water. I did it 3 times in total, and after the third one, it was still a bit blue, but that was okay. Now that pretty much all the other metals were gone, I added concentrated hydrochloric acid. I brought this to a boil and then I started adding small amounts of concentrated nitric acid. On their own, neither of these acids are able to dissolve gold, but together they make something called aqua regia, which is actually able to. They work together where the nitric acid starts by oxidizing an extremely small amount of the gold to make gold 3 plus ions. This reaction is really unfavorable though, and almost immediately after they're made, they revert back to being metallic gold. With the hydrochloric acid present though, it can attack the gold 3 plus ions and convert them to chloroauric acid. This breaks the equilibrium between the gold and the nitric acid, and the gold ions are continually fed forward to make the chloroauric acid. I kept adding nitric acid until it pretty much looked like all the gold was gone, and then I left it overnight. The next day, I still had some solid stuff at the bottom, but it wasn't gold. It was all just silver chloride, because apparently there was still some silver left in the gold. So moving on, I diluted it with an equal amount of water. This is done just to knock out any silver chloride that might still be dissolved. Then on top of this, I added some concentrated sulfuric acid to knock out any lead that might be present. When refining jewelry, there usually isn't any lead to begin with, but this was just a precautionary measure. As far as I could tell though, nothing happened because there was no lead. I let this stir for about an hour, and then I filtered it off. This was done by just using a couple coffee filters, and the solution that passed through was really nice and clear. When it was done, I washed the filter paper with a lot of distilled water because as long as it was yellow, it meant that there was gold in it. When I eventually had a completely colorless filter paper, I took away the funnel and I dumped all of this gold solution into a larger container. I also washed the beaker a few times with distilled water to make sure that I transferred everything. Okay, so now the next step was to get the gold out of this solution, and to do this, I used potassium metabisulfite. I made a solution of it by adding about 120 grams to 200 mils of distilled water. I thought this was enough to dissolve everything, but it wasn't, so I just kept adding more water until it all disappeared. Normally, I would have just dumped in all of the metabisulfite, but I thought that maybe it could be interesting to add it dropwise. The moment I did, some brown gold powder started precipitating out, but it wasn't particularly interesting. So I ended up just scrapping that whole idea and dumping in the rest of it. The potassium metabisulfite is a reducing agent, and it reduces the gold in the chloroauric acid back to its uncharged metallic form. It also reacts with leftover nitric acid though, which is why it was important to use a minimal amount of it when I was dissolving the gold. Other metal salts, like those with copper or iron, won't be reduced by this, and this whole step was to help further purify the gold. As one point of safety though, this reaction releases quite a bit of sulfur dioxide gas, which is dangerous to breathe. I'm personally really sensitive to it, and even very small amounts can trigger some asthma symptoms. So for this reason, it's extremely important to do it in a well-ventilated area, and I did it in my fume hood. I then let it sit for a couple hours to fully react, and for all the gold to settle down to the bottom. This was what I had a few hours later, and I dumped off all the water. All of the gold was then transferred to another beaker with the help of a bunch of distilled water. This was all brought to a boil, and after heating it for a couple minutes, I dumped off the water. This washing step was then repeated 4 more times using boiling distilled water. At this point, the gold is usually pure enough, but I wanted to get it as pure as I possibly could. So I decided to do another washing step, except this time with boiling hydrochloric acid. When the concentrated acid was added, it became yellow because an extremely small amount of gold was able to dissolve. The amount, like I said though, was extremely small, and it was nothing worth worrying about. This was brought to a boil, and I repeated the same thing 4 times, and each time, the solution became more and more colorless. After the last one with the acid, I did it 2 more times with boiling distilled water. Now just as a quick comparison, if we look at the gold before the acid and afterwards, it's quite different. The color of it is a lot lighter, and apparently, this indicates a higher purity. I poured off as much of the water as I could, and then I put it back on the hot plate to dry it. When most of the water was gone, I mixed it around a bit, and I let it sit on the hot plate for another several minutes. I also occasionally stirred it, and eventually I was left with a really dry powder. This was more gold than I had ever held in my life, and when I weighed it, it came out to be about 75 grams. Based on the carats of the chains, I expected to get